Hey guys, Oric here. Another video. This will be the second half of the practice final and questions 21 through 40. This one has a bit more calculator stuff on there, so it might be a little more time consuming, unfortunately. And so for this first question is basically what are the different characteristics? Oh, this is question number 23. Let me step back here. There's question 21. A survey for his statistics class collected data from 1,200 people that he knows. So in other words, it's not a random sample. He picked people that live close to him, that were easy to get to, and then what can you say about his results? Because the statistics weren't random, and he picked people that were close and made it convenient, it's going to suffer from bias. So that's going to be C is the correct answer. Some of these are multiple choice. On the actual final, they're all multiple choice. But it's biased, so it's either going to be A or C. If there's something in there that says it's completely random, then it's a good sample. All right, question number 22. It's a 5-number summary. So here is our, goes back to chapter 5 if you want to take a look at that at all. So if we did a 5-number summary, now remember 5-number summary is you put in all the data into the calculator and it finds the median, which is this number. This is your minimum, this is your max. So you have your min, middle, your median. It's the middle number. If you took all the numbers, there could be 1,000 people. The middle number is 74. And well, if it's a Katy Perry concert, there's probably several thousand people. Kind of your average cost is $74, but half the people spent more than $74, half the people spent less. And this is your max. And then what these other two numbers are is Q1 and Q3. And what they are is you take this top half of the numbers, several thousand people between $74 and $89 they spent. Nobody spent more than $89. And on this one now, that's your new minimum. And Q3 is the middle between $74 and $89. It's not an average between the two. Just half the people are between $81 and $89, and half the people are between $74 and $81. And it's half of half. So it's really a fourth of the people are between 81 and 89, and a fourth between 74 and 81, and a fourth between 67 and 74. And that's how these things work. There's a fourth between each one. So if you graph this out and went 10, 20, and tried to make it somewhat scaled, 40, 50, 60, 70, and I know this isn't exact, but hopefully this will get you close here, and then 89, and it's a little bit hard to read, I know, sorry. That's 80. So the minimum number was 10, and a fourth are between 10 and 67. So right about here. And then 67 to 74, and 74 to 81. And from our box plot, it would look like this. Q1 to Q3, a line there at the median at 74, and then a max. And this has a long tail to the left, so that's skewed to the left. I won't spend any more time on that. Here is same thing with the Katy Perry concert. Calculate the mean, median, mode, IQR. So you put it in the calculator. You click on Stat. Hey, dog. Stat. Stat, enter, and edit. We clear, arrow down, arrow it up to L1, hit clear. Basically in list one, we're just actually going to use one list on this one. I'm going to put all these numbers in 9, 4, 5, 14, 3, all of those numbers. So I'm going to pause the video for a second and put those numbers in. Okay, I just put all these numbers in. You can see the last group of numbers here. There's 24 total numbers. Number 21 is the 24th number. That's what this means. So I'll hit second and quit to get out of here. And I want to find the mean, median, mode. Now the mean is all of them added up and divided by 24. The median is the middle number. So if you did do this manually, you could put them all in order. And it's just the middle number. Mode is just the one that shows up the most often. IQR is Q3 minus Q1. It's the one that they won't give you on the calculator. And the range is the max minus the min. So let's see what we got here. Stat, and what does it say? Which one is not correct? Stat, calculate. So I hit the stat button, I arrow over to calculate, and it's one variable stat. So I just have one variable that I'm dealing with. And list one, calculate. Mean is this first one, X bar 10.04, so that's correct. I scroll down, there's my median is 8, and it says median is 8.5. So that one is actually the wrong one. Mode, well, let's do the IQRs. 13 minus 6.5, which is 6.5. So 13 minus 6.5, and the range is 29 minus 2, which is 27. The mode, to find the mode, you can look and try to see. It looks like it's 8, just from all the number of 8s. But the other way to do it is if you click on this stat and sort, and then I sort list 1. If I hit alpha or second and list 1 and sort, and then when I go in here, hit stat and edit again, it puts them all in order. And you can see there's 3 number 7s, 4 8s, a couple of 9s. So there's 4 8s, which is the mode. Mode is the most. Most. Medium, middle number. So that's how you remember median, and mean is the average. Add them all up and divide by how many there are. All right. Okay. Now what we can do on here is, it might be best just to kind of think about this, but if we want to, we can actually go in and look at, see what happens. Our person that picked 2 meant to write down 5. So if we go in, we can change our list here. This is the same list, it's just now it's in order. And I take that 2 and make it 5. And I can just overwrite it. And now I hit stat, calc, one variable stats. You can see my mean changed. What would change? Well, if we're adding them all up and dividing by how many there are, that the mean is going to change. So the mean is going to change. The range is going to change because 2 used to be our lowest number. Now our lowest number is 3, so the range changed. The middle number, if you think about 24 numbers, there's 12 numbers in this group and 12 numbers in this group, and we change, flip-flop a couple of numbers here and make one a 2 and a 5. Well, the middle number is still the middle number. So the median doesn't change. And the Q1, the IQR, the Q middle of this and the middle of this didn't change because all we did is change the minimum. So the IQR doesn't change. And we just said the median doesn't change, so it can't be that one. And 8 still the one that shows up the most often. If 5 was close to it, maybe the mode would have changed, but the mode didn't change on that one, so it can't be that one. So the mean and the range changed when we changed our changed that 2 to a 5. If you look, here's our median is still 8. Huh. It actually did change. On the test, they made it so that was we had one that was like an 8 and a 9, I think, and so it moved it over 1. The mean and the range would definitely change. The middle usually doesn't change. Oh wait, no, the median was wrong on that one. It wasn't 8.5, it was 8. Okay, good. So the median shouldn't have changed. All right, so stem and leaf plot. Back to chapter 5 again. So this stands for 60 stands for 60 inches. So this is 59 inches, 62 inches, 63 inches, 64 inches. That's how you read a stem and leaf plot. Here's all our list of numbers. So we have them here. They're listed here. Which value is left out? Well, we got 59, 62, 63, 2 64s, a 65, 1, 2, 3 66. We only have 2 66s here. So one of these 66s was left out. That was a pretty easy one. What can you say about comparing these two stem and leaf plots? Well, 3/4. Remember, each of these is 25%. 25% there, 25% there, or 1/4, 1/4. So you got 3/4 of the people in period 1 are in the top 25%. So 3/4 of the whole class did as good as just only 25% in period 5. So, and the median is quite a bit higher. Their middle number. You want to compare these boxes. The box is the middle 50% of the people. So you always have some on the top, some that are down here in the bottom. Middle 50% of the people is these two boxes. And this class, period 1, is clearly better. First period did better. First period, so it's either going to be B or E. First period better, 75% of the students scored higher than 60 compared to only 25% in the second period. So E is the right answer. 27. This is we didn't spend a whole lot of time on this, but this is a deceiving graph. And the reason being is we don't start at 0. So, and this should be 70, this should be 65, and somehow when I copied this over, it didn't show up right. But we started at 60, and so we went from like 67% to 70%. So it looks like this, and I forget which it is. Sorry, that graph got skewed. This should be Minnesota, and this should be Wisconsin. So what it is, it looks like from the graph that Minnesota did twice as good as Wisconsin. But in reality, Minnesota had about 3% more people voted. And it doesn't tell, Minnesota might have half as many people. This is just a percent. So A, we don't know. Half as many in Wisconsin? No, it's just about 3% less. Twice as many in Minnesota? No. Minnesota only had about 6% more. Okay, so that's 65. I can't, my numbers don't line up. But this is one, it's about 6% more than Wisconsin. So be careful when you see these graphs where so this is 70. This must be 65. I don't know. I can't tell how that's even supposed to be here. It says 6% more, so this must be 5%, and this must be 60. And so, yeah, this is 0, and this is 60. So this is like 63, and this is like 70%, or 64 and 70. All right. So this is a skewed to the left. There's a tail to the left. So what that means is mean is to the left. Skewed to the left means mean to the left. Mean is going to be left or less than the median. Mean is less. Median will be larger. You don't know anything about the mode, so it can't be that. Mean and median. The mean is less than the median. There we go. And we don't know. So you know it's going to be either A or C. They're going to be talking about the mean and the median. And it's just because the mean gets affected more by outliers than the median does. All right, question number 29. Oh, shoot. If you removed this one here is an outlier. If you remove outliers, the correlation gets stronger. If you remove every point that's not exactly on the line, the closer to the line, like this one would be a line. Let's put a line in here. A line would be something like this. You get rid of this point, these dots are closer to the line, the correlation will get stronger. All right, question 30. Here's a scatter plot. We'll predict at somebody that got 175 go up to the line. Don't look at the dots. And maybe I'll go a little bit different color here. And I'm not sure if I got that or not. And try to make it level. And this is multiple choice, so it's somewhere between 375 and 500, probably closer to 500, so probably like 450. So just do your best guess. Somewhere between 375 on the test, the multiple choice answers, it's going to be numbers that aren't too close together. I think I would guess, if this would be about 400 there. I would say about. And that's actually going up just a little bit. I'd say 450 to 475. All right, question number 31. What score for somebody that just plug in 10 for X? Oh, nice color. So we got 250 plus 15 times 10, or 150, equals 400. That's what the linear regression line does, is you can predict values based on whatever X we plug in. What does the X represent? For every one X goes up, like if X is at 1, you got 265, X goes up another 1, you go up an extra 15. So for every extra hour, it goes up by 15. I'm going to get rid of that color though. So decrease, no, it's going up positive 15. Can't say it's going to automatically, it's going to score something. And it won't automatically increase, but that's what you would predict. So anything with automatically, you can automatically eliminate automatically. So this one's fairly easy. So they're either going to get a better score, or every time you study more, that's going to go up 15. All right. I did it again. One more question down here. 33. So this is linear regression. So here you would put the two lists into list 1 and list 2. You click on Stat, Edit. I'm going to clear that out of there. And list 1 is 100, 102, and I'm going to pause and put the rest of these numbers in. Okay, I put both of these lists in, and then what we're going to do is linear regression. That's Stat, Calculate, and number 4. Oops, I got list 3 in there from not sure when. List 1 and list 2, I put those two lists in. And FODS, form is linear. And this is a multiple choice, so all of them are going to be form. Form is linear. Correlation, R, is 0.93. Remember, the closer you get to 1, it's strong. So it's strong. There's no outliers. That's the O. Direction is positive. Positive. On the actual test, it's the multiple choice. It'll say something to the effect of a strong positive linear relationship between club and head speed, and there are no visible outliers. That's form, direction, strength, and outliers. All right, question number 34. And do I got to do this again? So if you look at that, they actually made a scatter plot, and you can tell those dots kind of follow in a pretty solid line. So I would say something about like this. What is the question? Which of the following conclusion to make? So the correlation. There's a high positive correlation between jars sold and classical CDs sold. There's not a cause and effect relationship. So anytime you see cause, it's not right. So cause, it doesn't cause you to get hungry for jam. You don't know about how many people like it or dislike it. It's all about correlation. As the number of jars goes up, number of CDs sold goes up. And maybe there's an outlier here that's causing that to happen. Or something else is causing it, not actually jars of jam, but for some reason there's a strong correlation. Lurking variable, that was the word I was looking for. Something we haven't thought of that's causing that to happen. All right, 35. So this is a way to test, how well does somebody do on one test versus another test, and you compare z-scores. So the higher the z-score, when you get out here at 3 standard deviations, that's a z of 3. That means you're up there in the 99.9 percentile. And -1, -2, -3. So we can compare how we did on these two things. And the formula, and this will be on the formula sheet, z equals x, which is your score, minus the mean over the standard deviation, which sometimes is written like this. And she scored a 625. Okay, so we're comparing the ACT and the SAT. And the ACT, she got a 625, and the mean was 450. Oops, 450 over 100. Make sure you subtract first, then divide. Do the numerator first, and that comes out to be 1.35. On the SAT, she got a 28. The mean was 21, and the standard deviation is 6. That's 1.17. So both of these are right in this general area, just a little bit over 1. This is actually the 84th percentile is at 1, so that she's right about 85th percentile. But she did better on the ACT, 1.35 for a z-score. 36. Now this is where we have to use our table, our Z table. I'm going to pause this for a second, pull that up here. Okay, so here is our basic, just kind of helpful to just do a quick graph. The mean is 183.4, and then add 3 standard deviations to it. So you would add 31.8, add another 31.8, add another 31.8, and subtract 31.8. I'm not going to write that all out, but that gives you an idea. Weighs less than 180 pounds, so they're pretty close to the mean here. It's going to be less than 50%. So once again, that formula is Z equals X, which is our score, minus the mean over the standard deviation. And then we look the Z up on the table. So Z equals X, which is 180. So how much does somebody that's 180 minus 183.4, which is our mean, over the standard deviation, which was 31.8. And if you calculate that all out, you get a negative 0.11. Negative 0.11. That's our Z-score. We're just, Z of 0 is the mean. So we're just a little bit below the mean. Now there's the Z table, but I have it on here too. Here's the negative side and the negative 0.1. And here's the 1. So 1 over negative 0.11. 0.4562. So that's 0.4562, or 45.6%. More than 210, so we got to do the same thing again. 210 minus 183.4. And that, now this time we're going to be, kind of over in here. And we're going to go more. So it's going to be less than 50% again, because the Z table is going to give us a number that's going to give us less. 183.4 over 31.8. That's our Z score. And that comes out to be, remember to do the numerator first, 26.6 over 31.8. That comes out to be a positive 0.84. So I look that up, the Z table. Here is the positive side, 0.84, 0.7995, which equals 0.7995, or almost 80%. Now that gives us the amount from there and below. So we got to go 1 minus it to get our amount over 210 pounds. So that's going to be 0.2005. And the next question is, what's the Z-score for a man who weighs 210 pounds? Z-score, we figured out, Z equals this, 0.84. So they should ask that question first, but they asked the Z-score after. All right, 39. 75th percentile. So here's your table. Remember, it's 68% in between. So here at 1 standard deviation, that's 84th percentile. So he's kind of about right here. He's at the 75th percentile. And what that means is he's at 75% of the people are below him for the mile run. So he's faster than 75% of the students. Yeah, there we go. Zachary ran faster than 75%. He ran only 25% ran faster than he did. And last question here. I know this is kind of time consuming. And of course it's another data entry one. 15 students. Which measure of center shows best representation? We almost always use the median. And the reason being, the 65 here throws the data off. And it makes it look like everybody's scoring a lot higher than they did. And if there's not an outlier, then the median and the mean are both good, because they're going to be pretty much the same. And even the mode will probably be really close to that. And that's what a normal distribution, the median, mean, median, and mode are all the same, right in the middle. But the middle is the best when there are outliers. It gives a better representation. And that's it. Sorry for the long test, but at least this one there's only one video.